In this video, we're going to use the empirical rule. So take a moment to pause and read the full problem statement. The first thing that I suggest doing when we're given problems and we're told to use the empirical rule is to draw a representation of this as a normal curve, determine the values that would be on those important tick marks, and I've already done that here. So I was told that the mean was 600. I was also told that the standard deviation was 53. So I used that standard deviation of 53 to then fill in 3 standard deviations above and 3 standard deviations below the mean by either adding 53 or subtracting 53. Next, we do want to use the empirical rule, obviously. That's another name for this rule is the 68, 95, 99.7 rule. It tells us that 68% of the data is within 1 standard deviation of the mean on a normally distributed curve. It also tells us that 95% of the data is within 2 standard deviations of the mean. And 99.7%, that's almost all of the data, are within 3 standard deviations of the mean. This particular graphic is in our e-text, also in our class presentations, and it further breaks down some information by smaller segments. Like, for instance, this piece that's 1 standard deviation above up to 2 standard deviations above is only 13.5%, for instance. One other implied rule within the empirical rule goes back to the fact that this is a symmetric curve. So if we know that the mean is in the center, half of the data is above the mean and half of the data is below the mean on this normally distributed curve. So when we go back to our problem using our particular graphic for this problem and we answer 99.7% of light bulbs have a lifetime between what 2 time spans? We know that 99.7% of data fall within 3 standard deviations of the mean. So we've already completed that. Whenever we come back to using this tool, we see that 3 standard deviations below to 3 standard deviations above, that would be from 441 to 759. For the next question, assuming, again, bell-shaped, determine the percent of light bulbs that have a lifespan between 494 and 706. So we come back to the tool that we created. 494 is 2 standard deviations below. 706 is 2 standard deviations above. So within 2 standard deviations of the center, the empirical rule says that 95% of the data is located here. So quickly, we can determine 95%. Now, the next 2 questions will also use that other piece of normal distributions, which is that they are symmetric. So for this next one, we're looking for the percentage between 547 and 706. When we come back to our tool, we see 547 is 1 standard deviation below. 706 is 2 standard deviations above. You have some options here. If you have a more complete empirical rule graph, or you would like to memorize all of these values within, we could add up 34% plus 34% plus 13.5%. Because if I imagine this same graphic overlaid with my values, that's the area I'm trying to compute. That's one option. Another option is to use the symmetry and just the numbers 68, 95, or 99.7. More in particular for this question, it's the 68 and the 95. So let's look at this in halves. So we know the top part, I guess I could say top part here. I'm going to see if I can shade this here to better explain. From the mean to that second standard deviation mark, this region here would be half of the 95% from the empirical rule. So we could calculate that value, and what you see here in yellow is 47.5%. Let's do the same for the other part. The area between one standard deviation below to the mean would be this region here in green, and it is half of that value associated with one standard deviation within the mean, the 68. So half of that is 34. So we could continue just to use the values 68, 95, 99.7 and the symmetry to determine that from 547 up to 706 would be 34 plus 47.5%. And when we add those values, that's also another way we could arrive at 81.5%. The last question asks about bulbs that do not last at least 441 hours. What percent of bulbs would they have to replace? So let's find that value on the curve that we drew. Here is that 441, and we're looking at this small section. I mean, it's so small we can't even see it here. But the 441 is 3 standard deviations away from the mean. There's a value associated with that in the empirical rule. It is 99.7% of the data fall within 3 standard deviations of the mean. So what falls outside of it? If all of the data is 100%, 100 minus 99.7 would be 0.3%. That 0.3% would be located here and here. But we only need half of that because we're only looking at these values. So let's take 0.3%, divide it by 2, and we get 0.15%. So again, some ways that we can use the tool of just sketching a normal curve, filling in those values for mean and using the standard deviation to fill in the rest, as well as our normal curve and this empirical rule.